Thanks for joining me. In this video, we're going to discuss Euler diagrams. And an Euler diagram is just a visual way to try to determine the validity of a deductive argument. So remember, a deductive argument is starting from a general statement and then moving to more specific examples. So here is how you would do this. First, you're going to draw an Euler diagram based on the premises of the argument. So it's really kind of similar to a Venn diagram, but usually what happens is one circle lies within another rather than overlapping. A lot of times it works out where you have one circle and another circle lies within that circle. And we'll see that as we move through some examples. The argument is invalid if there is a way to draw the diagram that makes the conclusion false. The argument is valid if the diagram cannot be drawn to make the conclusion false. In other words, there's only one way to draw the diagram based on the information given. If the premises are insufficient to determine the location of an element or a set mentioned in the conclusion, then the argument is invalid. So let's look at some examples and see what they're talking about. So use an Euler diagram to determine if the argument is valid. So first we see all cats are mammals. So I can draw an Euler diagram, which is basically a special case of a Venn diagram. All cats are mammals. So that means I could draw a circle in here. The big circle would be mammals, and then the smaller circle would be cats. Anything that's a cat is going to also be a mammal. So that circle lives completely inside the mammal circle. Now we look at a tiger is a cat. So a tiger must live in the circle of cats. So it's one specific type of cat, right? Then the conclusion is a tiger is a mammal. This is the only way to draw this diagram. You couldn't put tigers out here because then it would be in mammal, but it wouldn't be in the cat circle. So that wouldn't be okay to do. You also couldn't put it outside of the circles. It has to be inside the cat circle, which is completely inside the mammal circle. So the conclusion, a tiger is a mammal, is true. It's valid. There's only one way to draw the diagram, and it supports the conclusion. So this is a valid argument. And a valid conclusion, I guess I should say. Number 2, all firefighters know CPR. Okay, so CPR is the big circle because there are other people that know CPR as well. So firefighters live inside of this circle. So all firefighters know CPR. Jill knows CPR. So that means Jill has to be inside the CPR circle. But there's two different places we could put Jill. We could put Jill here, or we could put Jill here. All it says is that Jill knows CPR. So we don't know where Jill is. So can we conclude that she's a firefighter? No, we cannot, because we could have drawn the diagram with Jill out here, right? So this is not a valid conclusion. So invalid, because we don't know where we should put Jill. So a lot of times, whoops, let me get to where I need to be here. Instead of putting Jill in both places, which is fine to do because you don't know, you might mark an X on the line, meaning it could be inside the circle, it could be outside the circle, we don't know. So that's another way to kind of illustrate this. Number 3, all cats are scared of vacuum cleaners. So we have a big circle for scared of vacuum cleaners. I'm just going to put VC. So they're scared of vacuum cleaners. And then we have cats inside the circle. So all cats are scared of vacuum cleaners. Then it says Max is a cat. So I'd have to put Max inside the cats. So notice if it's valid, it's giving you a specific statement that's that allows you to place the X inside the smaller circle. It's going to be valid in that case. Then you can say Max is scared of vacuum cleaners. Since there's only one way to draw this, Max is inside the cat circle, which is fully inside the scared of vacuum circle. This is a valid conclusion. All right, our last example. If you live in Seattle, you live in Washington. So in this case, the big circle is Washington, and the smaller circle is Seattle. So if you live in Seattle, you live in Washington. Marcus does not live in Seattle. So that means I can't put him in the Seattle circle. I could put him out here. But notice there's other places to live besides Washington, right? So he doesn't live in Seattle. He could live in Washington, but he could also live outside of the large circle, which is somewhere other than Washington. So in this case, we don't know if we should put Marcus in the bigger circle or outside of the circles altogether. So since we don't know where to put him, let's see, our conclusion is Marcus does not live in Washington. Well, that's not necessarily true because he could still live in Washington, just not in the city of Seattle. So this would be invalid.